So each vector has a magnitude. Okay, what's magnitude? Length. When you see magnitude, think length. So we want to talk about the magnitude and direction of the vector. Okay, so the standard assumptions, the tail of the vector is at 0, 0. And so you see this picture over here. Theta is measured in the standard way. It's measured from the positive x-axis. So the angle that we're referring to here is the angle of the arrow that the vector v makes with the positive x-axis. And it's the usual thing. If you create theta with a counterclockwise rotation, theta is positive. If it's a clockwise rotation, theta is negative. Okay. So what's the length of this thing going to be, you guys? The length of this vector in red? I kind of break this class up into major themes. The very first major theme that we talked about, remember, was the Pythagorean Theorem, right? Yeah, the next major theme is the 6 trig functions. We're back to the Pythagorean Theorem, aren't we? Yeah. These ideas, SOHCAHTOA is another major theme. These ideas repeat over and over again in trigonometry. And many of them in math as well, in algebra, that is. So if you drop this perpendicular and create your friend, the right triangle, then again, now this time I'm going back and forth. Just for simplicity, I'm representing the horizontal component of V with A and the vertical component with B. I'm fickle that way. And so you could think of the length of that side as A. The adjacent side to theta is A. The opposite side you can think of as B. Keep in mind, A and B, if you're in another quadrant, A or B or both could be negative, right? So they could be directed lengths. But that's not going to matter for the length of the hypotenuse, which is the arrow itself. So what's that length going to be? By the way, we're going to assign that a notation. Magnitude V is represented by double vertical bars. So the length of V is represented by double vertical bars. So if I write this down, you're going to think length or magnitude of V. Some books use single vertical bars, and you don't get that confused with absolute value because you know it's a vector, not a number. But your book uses double absolute or double absolute value. No, double bars. So what's the Pythagorean theorem say then? That the length of the vector in red should be? Yeah, you got to remember to take the square root, right? But yeah, square root of a squared plus b squared. And again, that works because the initial point, the tail of the vector is at the origin. And we also know from trigonometry the relationship between theta, b, and a, and the function that gives us that relationship. What function relates well, what is b in relation to theta? What side is it? Opposite side, what is a? Adjacent, so what function relates the opposite and the adjacent? So tangent of theta is equal to b over a. There's another idea that's repeating, right? That's the TOA part of SOHCAHTOA. Okay, so these are the two formulas you use to help you find the magnitude and direction angle of a vector. Okay, so in this example, let u equal -3, 5. Let's find the magnitude. So when you read this, think magnitude of u or length of u. Let's find the magnitude of u and the direction angle theta. So what does the formula tell us that the magnitude should equal? Well, it's the sum of the squares of the components, and then you take the square root, right? That's essentially what it said. So what would that look like? The square root of? Well, -3 squared, right? So that negative's going to go away. You don't have to worry about it. So plus what? Plus 5 squared. So all that's going on underneath the root. So what does that give you? The square root of? So 9 plus 25, 34. And so that's it. That's the length or magnitude of u. It's not so bad. Okay, what would I do to find the direction angle theta? Well, before you find the direction angle, find the tangent of the direction angle. What would that be? Tangent of theta is equal to, it's always the second component over the first component. And there's an interesting observation here, if you want to make it. Wouldn't that be the slope of the arrow? So yeah, the tangent is equal to the slope of that arrow that represents the vector, isn't it? Yeah. So it's the change in y over the change in x. You could put it that way. Or rise over run. Heck, you could put it that way. Okay, so you have to be careful here. Let's get a decimal approximation for theta. Take your calculator out, if you would. But make a prediction for me. So I'm going to take the tangent inverse of both sides to help me figure out what theta is. And when you plug it in the calculator, you can include the negative if you want. So it'll be in front, but that's the same thing. So take the tangent inverse of negative 5/3, but before you actually hit enter, predict for me which quadrant that will be in, based on what you know about the tangent inverse. Which quadrant will the tangent inverse of negative 5/3 be in? It'll be in the fourth, because the tangent inverse is only defined in two quadrants, first and fourth. And when you take the tangent inverse of something negative, something in the fourth quadrant pops out, right? What quadrant should our angle theta be in? If you graph, so again, you want to think of the tail of u as being at the origin, right? In this kind of scenario, when you're finding theta. So what quadrant would u equals negative 3,5 be in? Remember, when it's in that sort of form with the tail at the origin, you just plot the point negative 3, negative 5, and then draw from the origin an arrow to that tip at the point negative 3, 5. So what quadrant is that in? It's if you just draw it real. Here's x, here's y. The tail of the vector is at the origin. You go negative 3 up 5. Whoops, a couple more. 1, 2, 3, 4, 5. Not the best picture I've ever drawn, but you'll get the idea, right? Obviously, that's in the second quadrant, isn't it? This guy's in the fourth quadrant. Not what we're after, is it? Notice I didn't say this thing's equal to theta just because I knew that was going to happen. It's not theta. Okay, so run that through your calculator. Tell me what you get. Just round to one place past the decimal. Good enough. Yeah, about negative 59.0. Is that what you're getting? Okay. Degrees. Oh, okay. So yeah, that's in the fourth quadrant. Well, you could use a reference angle here, couldn't you? So what we're getting is the version of this thing in the fourth quadrant. This guy's the negative 59 degrees, right? This angle right here. So couldn't we think of alpha, our reference angle, as 59 degrees? And that's got to match up right here. Yeah? So what do I do then? If I know that this angle here is 59 degrees, what do I do to get theta, which is this angle here? Subtract from the straight angle of 180, right? Okay. So theta then, so we're back to trig stuff, right? Reference angles. So theta is going to be equal to what? 180 minus 59.0, or just 59 we'll use. What is that? Obviously, that's an approximation, right? Well, what do you get there? 121. So theta is approximately 121.0 if you want to put in, how accurate we were being there. Any questions there? So we've got our magnitude, we've got our direction angle, we've done everything we were asked to do.